Right, we're going to have a look at a couple of different things in this part of the topic. We're going to look at momentum, we're going to look at car safety features, and we're also going to look at terminal velocity. Now the first thing, momentum. A moving object does not just have kinetic energy, it has another property called momentum, which is related to the mass and the velocity of the object. And you can calculate it using this calculation here. So really that's all it is. Momentum is the mass times the velocity, and if you remember, velocity means how fast something's going in one direction. So it's a fairly straightforward equation, and you can see it's been put into a triangle for you again, but if you look at the bottom, then there's another equation there. So the force then equals the change in momentum divided by the time in seconds. So please be aware which one you are looking at, okay, because the one at the bottom is when the momentum of an object changes and there is a force on the object. So you need to make sure you can work that out first and then apply it. Now obviously when we're talking about momentum, we're talking about things that are moving, and obviously the mass is going to increase the momentum, and the velocity, how fast something is going to increase the momentum. It's sort of common sense really. If we look at that in terms of car safety features, then you'll see that a lot of designers and scientists do a lot of work to make sure they look at the science behind different collisions, and they make sure that cars are as safe as possible, and they have some of these features that they work on a lot to make sure that they are the best possible thing, because if there's an accident, it doesn't matter if the car gets destroyed, it's all about saving the people inside from as little damage as possible. So in a collision such as a car crash, there is a sudden change in momentum. A large force can be exerted on the passengers by rapid deceleration, which causes injuries. Seatbelts, crumple zones and airbags in cars help reduce injuries in a crash by reducing the momentum more gradually. Each of these features also absorbs some of the energy of the collision and transfers it into a less dangerous form. So you can see there I've used the scientific keywords to explain what's going on. It's all about the energy and how it's transferred and absorbed in a collision. So make sure you use those sorts of words. So if you looked at a seat belt, for instance, seat belts stretch slightly rather than holding a passenger completely rigid. Now you might think to yourself, well hang on a minute, when there's a crash the seat belt locks, but it does actually stretch a little bit as well. And doing that stretches the seatbelt fibres, and that's what absorbs some of the energy. Crumple zones on cars, they bend, absorbing some of the energy of the collision rather than resisting it as a stiffer piece of metal would. So things like the bumpers on cars, they're actually designed to absorb some of the energy without it being transferred to the passengers inside, and that's usually because they're made of really either soft metals or plastics that can bend rather than a solid piece of metal which wouldn't and would just transfer it. Airbags create an air-filled cushion to slow the passenger gently, ensuring they don't hit the solid steering wheel or car interior. Okay, so again it's absorbing the energy of the person, moving the momentum of the person as they're transferring through. Collapsible steering columns, these actually bend, absorbing some of the energy of the collision rather than resisting it as completely rigid steering column would, and again really useful. Seat belts have to be replaced after a crash because they stretch during the accident and do not return to their original shape. In another crash they would not stretch when needed, and as a result they would not be able to absorb any of the energy of the collision. Sudden change in momentum means a greater resultant force. The car safety features mean that they allow the occupants to keep moving just slightly longer so that they can absorb more of the energy, which we've talked about. Other things on cars, and you'll see there's purple features and there's blue features. So the purple features are there to protect the passengers. So we've looked at collapsible steering columns, crumple zones, airbag, seatbelts. The other one I didn't mention there is safety cages, which are used to strengthen the actual cabin section itself. If we look at the black features then, the brakes, these are features to prevent the accidents in the first place. The brakes reduce the speed of the car by transferring kinetic energy to heat energy very quickly. Anti-lock braking systems prevent the tyres from skidding because it stops the wheels from locking up. Traction control prevents a car from skidding so the driver can quickly escape from a dangerous situation. Electric windows make it easier for the driver to open or close the windows when driving, causing less of a distraction. And then paddle shift controls allow the driver to keep both hands on the steering wheel when changing gear and adjusting the radio. So you can see there's a lot taken into account when it comes to vehicles. Now if we look at that in terms of friction and air resistance, frictional forces can act against the movement of an object, slowing it down, and this can be reduced by changing the shape or by using a lubricant. And we've talked about if you had a streamlined car, that would reduce friction. If you had something on the road like oil, that would be classed as a lubricant, and again that would reduce friction. So just remember some of those key terms. Now if we move on then, because we're still looking at momentum, but we're looking at moving in one direction, and we're looking at something called terminal speed or terminal velocity. Okay, and this is the most common example of this is looking at a skydiver. Okay, so if we're looking at a skydiver, for instance, you'll see this is a graph showing you what's happening. So when the skydiver first jumps out of the plane, his speed will increase, or his velocity will increase, because he's actually travelling in one direction, which is down. Then after a while the skydiver will reach its terminal velocity, because the skydiver is free falling as fast as it possibly can. So it will reach its terminal velocity. Then when the skydiver opens its parachute, the speed will decrease, and that's because you've created a larger surface area for the air particles to be trapped in, and that will decrease the speed. Please don't be falling into the trap, because if you watch a video of a skydiver falling and they open the parachute, it looks like they shoot upwards, but actually they don't. It's because they are falling at the same speed as the cameraman, and the skydiver opens his parachute but the cameraman doesn't. So the skydiver reduces his speed dramatically, but the cameraman just carries on falling, and that's why it looks like he's moving upwards. Once the parachute's been opened and the air particles are going into the parachute, the parachutist then, the skydiver, will then reach another terminal speed, another terminal velocity, but this time at a much slower rate. Okay, so a lot to take in there, looking at momentum, looking at features of cars that help to reduce momentum if there's an accident and to absorb the energy, and then looking at terminal velocity. Terminal velocity means the fastest you can possibly go, and looking at how that applies.